In order for Earth to support human life, several factors must be right, such as the distance of the Earth from the Sun. The Sun provides energy, light, and warmth. Its dimensions and distance to Earth are essential for organic life as we know it.
For life on Earth, the Sun is essential. The Sun provides energy. The Earth is like an open system. We receive energy for free, ensuring that the Earth is warm and that biophysical processes can form in a stable manner and continue to do so. This supports life as we know it. If we switch off the Sun, we are left with darkness after 8 minutes, and 3 days later we end up at minus 150 degrees Celsius, and life on Earth would be finished in a short time, at least after all forests are cut down and burnt. Without the Sun, nothing goes. That sounds a little bit morbid, but that's the way it is.
In our Milky Way, the Sun is a small dwarf star, but the relevant processes for life on the surface of Earth depend heavily on the Sun's radiation energy. In 1 second, the Sun radiates as much energy into space as the whole of mankind needs in several 100,000 years. Not only that, but its power must remain largely constant to allow for life on Earth. More than 99.9% of the energy contribution to Earth's climate depends on the Sun.
The Sun cannot change in its radiation. If it suddenly heats up by 200 degrees, we start to sweat. Or if it cools down, we freeze. It is important that the Sun delivers a constant amount of energy over long periods. Computer simulations show that the Sun is delivering the same amount of energy over long periods of time, which is very good for us indeed.
Not only the power of the Sun, but also its distance from the Earth is significant for the existence of life on Earth.
If the Earth were closer to the Sun, the climate would resemble that on Venus. Water, which is a little lighter than carbon dioxide, would be high in the atmosphere and would therefore be disintegrated by ultraviolet light and would escape. Venus has no water. This would be absolutely hostile to life.
The planet Venus is uninhabitable because of its hot temperatures, up to 500 degrees Celsius. It's closer to the Sun than Earth.
On Mars, it would be too cold. When water is frozen, as on Mars, life is probably impossible.
So Mars is also uninhabitable. Here, temperatures are at minus 55 degrees centigrade on average. In order for human beings to live there, they would need a better atmosphere. For Earth to be habitable, it must be at a certain distance from the Sun, allowing for the existence of liquid water.
If Earth was closer to the Sun, temperatures would be too hot on its surface, and the oceans would evaporate. And for our life on Earth, water is very, very fundamental.
If the distance from Earth to Sun was too large, on the other hand, water would freeze, and again there would be no water-based life on Earth. 70% of the Earth's surface is covered with water. Water regulates the temperature on Earth, absorbing heat. Water is the basic solvent, transporting chemical components essential for life. Where liquid water is found, life can exist.
Water is the liquid on which life is based. A considerable fraction of molecules in our body is water. In every biological cell we find water, along with many biomolecules. Water has an array of properties which enable the existence of life on Earth, or facilitate it.
Human life is only possible when the Earth's orbit of the Sun lies in a limited region. Small deviations could cause catastrophic consequences for mankind. Another factor plays an important role to make Earth habitable: the angle of inclination of the planet's axis.
A distinctive feature of Earth is the inclination of its axis at an angle of 23 degrees, and ensures that we have summer on the northern hemisphere when the sun shines there, and after half an orbit, the sun shines more onto the southern hemisphere, bringing summer there. If the Earth's rotational axis was vertical, we would have nearly the same weather at every point throughout the year. But this would mean that at the poles, life would not be supported. There would be no seasons, and it would be too cold. And at the equator, it would be too hot. If we tilted Earth's axis to more than 23 degrees, there would be no nights and days, as the sun would only shine onto one side, almost like the midnight sun. On the other side, it would remain continuously dark, implying a substantial difference in temperature. So life could only exist within a limited area, and we would probably have large turbulences in the atmosphere due to the large temperature differences.
If Earth would be alone on its orbit around the Sun, its rotational axis would be very vulnerable. But the Earth is not alone. It's accompanied by one moon.
The moon is important for Earth, as it stabilizes Earth's axis, which is slightly tilted. If it were not for the moon, the Earth would start tumbling, and the course of our seasons would be destabilized. If the moon were closer, the Earth's rotation would be decelerated, including a substantially prolonged duration of the days. It would be quite discomforting if a day lasted 1 month.
Not only the moon, but also Jupiter contributes essentially to stabilize Earth. Jupiter is more than 1,000 times larger and about 300 times heavier than Earth. Due to its immense mass, it attracts comets and other celestial bodies, which intrude from extrasolar space towards Earth's orbit. Hence, a possible collision of these objects with Earth is avoided. Jupiter is like a protective shield for Earth. But danger for life on Earth originates not only from outer space, but also from our very own Sun. While it supplies necessary heat and light on the one hand, other components of its radiation are extremely damaging for life. For example, the so-called solar wind transports charged particles, which do not harm us, due only to the fact that the Earth's magnetic field deflects them. So they enter the Earth's atmosphere in the region around the magnetic poles. Thereby, molecules in the air are excited to luminescence, which is seen as the aurora borealis, the northern lights.
If the Earth's magnetic field ceased, we wouldn't be protected against cosmic radiation. These particles, charged protons, approach from the cosmos and arrive on Earth, where they are deflected by the magnetic field, so that we are shielded from damaging effects. Otherwise, the natural exposure dose and radioactivity we receive would be strongly enhanced.
Another factor which renders human life possible is Earth's atmosphere. In fact, some other planets and moons exhibit an atmosphere too. However, it's usually much too thin to facilitate an environment supportive of life. Among the life-supporting components of Earth's atmosphere is oxygen, at about 20% of the total atmosphere. This high concentration allows for the formation of ozone, which shields the Earth's surface from harmful UV radiation. Whether or not life is possible on Earth also depends essentially on the kind of electromagnetic radiation which reaches Earth's surface. Organic life is reliant on the small frequency range of visible and infrared light in the electromagnetic spectrum. This is vital for the photosynthesis of plants. The relevant biomolecules can absorb light in the infrared and visible range and process its energy. Surprisingly, the sun's radiated energy peaks exactly in this frequency range. Summing up all these observations yields one conclusion. Many factors are unexpectedly well attuned to each other and uniquely fine-tuned in order to allow for the existence of life on Earth, including the respective positions of the Sun and the planets, and the derived parameters like energy balance, light, and physical condition of water. Earth constitutes a unique place for organisms in the universe.